All right, y'all, so today we are going to start discussing quadratic equations, and we're going to begin discussing quadratic equations by graphing. So this is a 2-page document that is going to introduce quadratics to you and give you a few vocabulary words, and then we're going to graph and analyze our graphs of our quadratics. So there are a few vocabulary here that's listed that you're going to hear over the next several days. The first vocabulary is the standard form of a quadratic equation, which you've all seen this before. The standard form of a quadratic equation is y, well, let me change my pen, y equals ax squared plus bx plus c. The curve formed by a quadratic equation, and you'll see what this means when it says the curve, because all quadratics look essentially the same. But the curve that is formed by a quadratic equation when you graph it is called a parabola. Parabola. The formula for the axis of symmetry, which we're going to discuss the axis of symmetry and what it looks like visually, but if you wanted to use the formula and algebraically find the axis of symmetry, the formula for that is x equals negative b divided by 2a, where b and a is from your standard form of your quadratic. You would divide negative b, negative whatever your b is, the coefficient of your x term, divided by 2 times a, the coefficient of your x squared term. If the vertex is the highest point on the graph, it's called a maximum. It's called a maximum. And if a vertex is the lowest point on a graph, it's called a minimum. And I'm going to explain to you once we graph number 6 what the vertex is. We're going to discuss the vertex, and we're going to discuss the max and mins of the graphs as well. Okay, so we have our quadratics here. Let's start labeling them. So we're going to go to Desmos, because Desmos is our best friend. Desmos. And I want to make sure I'm at the Desmos, Louisiana. It's desmos.com/testing/Louisiana/graphing. And you should see a green bar at the top that states Louisiana LEAP 2025 version. This is the version that you will see on the LEAP test. Okay, so we're going to graph x squared plus 6x plus 4. So I'm going to go over here and I'm going to type x squared plus 6x plus 4. X squared plus 6x plus 4. And as you see, this is what it means by the curve. This is called a parabola. It's a curved graph. Okay, it's a curved graph. So this is the curve of the quadratic formula, x squared plus 6x plus 4. This is the parabola. That's what the parabola looks like. Okay. The axis of symmetry, the first axis. What is the axis of symmetry? Well, if I wanted to find it algebraically by using this formula, you could do x equals negative 6 divided by 2, because that's negative b, b is positive 6, divided by 2 times a, which is 1. So that would tell you that the axis of symmetry is where x equals negative 3. Now, if you wanted to see the visual, the axis of symmetry is where you can draw a vertical line straight down the middle of this parabola, and it cuts the parabola in an equal half. So right here at x equals negative 3, and between negative 2 and negative 4 is negative 3. If I draw a vertical line right here along where x is negative 3, it's going to cut that parabola in a perfect 1/2. In a perfect 1/2. So my axis of symmetry is negative 3. The vertex is the point in which the parabola changes direction. So I'm decreasing until I reach this point, and then I begin to increase. So my parabola is decreasing, then it changes direction, and I increase. So the vertex is this point, -3, -5, where the graph changes direction. The bottom of your it's not a hill in this case, we'll call it a valley. The bottom of your valley, okay, is -3, -5. So the vertex is written as -3, -5. -3, -5 is my vertex, the very bottom point. And that is called your minimum. That's your minimum. So the vertex is a minimum. The vertex is your minimum. Okay, you can sketch that graph here if you want. I'm not going to sketch the graph because I have the graph here. I can see the graph. Okay, now over here to the side, I want you to also write the number of solutions, and the zeros. This is something extra that I'm adding here because I'm kind of teaching 2 lessons in one. Okay. So if you got the paper in class, I already wrote this for you, but those VIP students that are using the PDF version, this is not written for you. So the number of solutions and the zeros, what does that mean? Well, what that means is the number of solutions means where does this graph touch or cross the x-axis? What are your x-intercepts? Well, I have an x-intercept here, and I have an x-intercept here. I have 2 x-intercepts, which means I have 2 solutions. I have 2 solutions because I have 2 x-intercepts. And another vocabulary word or another term that can be used to explain your x-intercepts or your solutions is called zeros. So that's why I wrote zeros. What are your zeros? Well, my zeros are going to be where x equals, let's go over here to the graph, where x equals -5.236 and x equals -0.764. Those are my 2 solutions where this graph touches or crosses the x-axis. And my 2 solutions, also known as zeros, are -5.236 and -0.764. So zeros are x equals -0.764 and x equals -5.236. Okay. Number 7. Now I'm going to speed up a little bit because I went over that in complete detail. So let's speed up a little bit and let's graph our next equation. Now I'm not going to retype all this. I'm just going to click and type in -2x squared plus, I'm going to change that 6 to an 8 and then change that +4 to a -5. I'm graphing number 7, -2x squared plus 8x minus 5. Now you'll see where my parabola is increasing and then it changes directions to decrease and it opens downward. It opens downward instead of upward. Okay, so what is my axis of symmetry? I would have to draw a line right here where x is 2 in order to split that graph in exactly half. So my axis of symmetry would be -2. X is -2. X equals -2. And up there, that's x equals -3. Okay, my axis of symmetry is x equals -2. What is my vertex? Well, my vertex is the point, and if you click and hover over that point, it will give it to you right there as an ordered pair. My vertex is the point which it changes direction. I'm at the top of the hill at 2, 3. So my vertex is 2, 3. And that vertex is going to be a maximum. My graph is increasing and then it's going down. That's the max point of my graph. So my vertex here is going to be a maximum. You can sketch it here if you want to, if you choose to, but it's not required. I'm not requiring you to because hopefully you're all using Desmos. So what are my number of solutions and what are my zeros here? So my number of solutions and my zeros comes from my x-intercepts. I have two solutions. Where my zeros in my two solutions are 0.775 and 3.225. So I have two solutions where x equals 0.775 and x equals 3.225. Okay, on number 8, y equals x squared minus 2x. We are going to go to Desmos, type in x squared, change that positive 8 to minus 2x and take off the negative 5, or you can just exit and retype it all in. X squared minus 2x, you'll see the parabola is now opening upward. It's opening upward. Our axis of symmetry is going to be where x equals 1, where I can split this parabola in exactly half and fold it over and it matches, okay? So the parabolas can be split in half at x equals 1. So the axis of symmetry is x equals 1. Now the vertex, where's the point in which the graph changes direction? I'm decreasing, I'm going down, and then at this point, you click and hover, it's going to start to increase. So the vertex is down here in the bottom of the valley at 1, -1. At 1, -1. And my vertex is going to be a minimum, because that is the minimum point. That is the minimum point of this graph. Okay, and you can sketch it there if you choose to. The number of solutions and the zeros. The number of solutions, also known as the zeros, come from your x-intercepts. Where does this graph touch across the x-axis? Well, it touches here at x equals 0 and x equals 2. So I have two solutions at x equals 0 and x equals 2. Those are my zeros, my x-intercepts, my solutions to this quadratic. Okay, number 9, negative x squared minus 8x minus 9. So I've got negative x squared minus 8x minus 9. Now I have a parabola that is opening downward, and my axis of symmetry is right here along this line where x equals -4. X equals -4 is the axis of symmetry. X equals -4. And the vertex is the point in which my graph changes direction. I'm increasing, I'm going up, and then at this point, -4, +7, it goes down. And this is the maximum. This is the highest point of my graph. -4, +7. -4, +7. And that is a maximum. And you can sketch if you choose to. The number of solutions and my zeros come from my x-intercepts. Number of solutions and x-intercepts for my zeros. Where does this graph touch across the x-axis? It touches here at -6.646 and -1.354. So I have two solutions at x equals -6.646 and x equals -1.354. Okay, now that I've done 4 of them for you, I want you to pause your video and see if you can do the remaining ones on your own and then come back and check your work. Okay, so I'm not going to flip back and forth from Desmos to graph and show you. I'm just going to give you the answers at this point. The axis of symmetry is x equals -2, and the vertex is -2, -6. Okay, and at that vertex, your graph would be a maximum. A maximum. Your vertex is a maximum point. The number of solutions number of solutions. I don't know why that J just showed up there. Number of solutions and your zeros for number 10. If you graph this, you will see that it does not touch or cross the x-axis. Therefore, your number of solutions are 0. There's no real numbers. Okay, for number 11, when you graph, you will see that the axis of symmetry is at x equals 0. Your vertex is at 0, -4. Your vertex is a minimum. And your number of solutions and your zeros are the x-intercepts, which there are 2, where x is -2 and x is +2. Number 12, the axis of symmetry is at x equals 1. That's the point in which the graph can be cut into 1/2. The vertex is at 1, -3, and that vertex is a maximum. The number of solutions and the zeros of that graph are your x-intercepts. And in this graph, there are also 0. There are 0. No solutions, no real numbers. For number 13, the axis of symmetry where I can cut that graph in half is at x equals 0. The vertex is at 0, 0. And the vertex is a maximum. And the number of solutions and your zeros are your x-intercepts. And if you look at the graph for number 13, there's only one. There's one solution where x equals 0. And then for 14, the axis of symmetry is x equals 3. The vertex is 3, -8 with a minimum. The number of solutions. How many times does it touch the x-axis? And your zeros, what are your x values where it touches the x-axis? There are 2 at x equals 1 and x equals 5. And the last one, number 15, the axis of symmetry is x equals -5, where you can cut that parabola straight in half. The vertex is at -5, -1 with a minimum. Your number of solutions, how many times does it touch the x-axis? And your zeros, what are your x values where that graph and parabola touches the x-axis? It occurs 2 times at x equals -6 and x equals +4.